let's talk for a moment about the fundamental theorem of calculus and try to get at its importance in connection with Riemann sums. Deal with the function y equals x squared, which you know is a parabola whose vertex is at the origin. Okay, so graph of something. And we know that at 1, the height of this would be 1, and at 2, the height would be 4. And we could use a left Riemann sum here and sketch it in a rectangle. And we might have a question with regards to the area under the curve. My first rectangle, since it's a left Riemann sum, has no height and a width of 1. My second rectangle has a width of 1 and a height of 1. And so the area under this curve would be 0 for the first rectangle plus 1, or a total of 1, which is clearly an underestimate, but still it's an estimate nonetheless. We can get more accurate if we increase the number of rectangles that we're using. So it's the same thing, but this time with 4 rectangles. With the 4 rectangles, my first rectangle has an area of 0 because it is 1/5 wide and 0 high. My second rectangle has a height of 1/4 and a width of 1/2. My third rectangle also has a height of 1/2, but this time it has a height of 1 and a width of 1/2. And the fourth rectangle has a height of 2 1/4 or 9/4, and also a width of 1/2. When we add these up, we find that its area of all those rectangles is 7/4, which is clearly pictorially more accurate than the first because I use more rectangles. I've got less extra space, but it isn't the exact answer because of the extra space. So we can see the principle that as we break this up into more and more rectangles, our method of approximation is better. And what the fundamental theorem of calculus ultimately is doing is it's allowing us to deal with what happens when the width of each of our rectangles from here to there approaches 0. It's a limit problem because we are ultimately going to have an infinite number of rectangles there, and their area, the sum of their areas, would be the area underneath the curve. The fundamental theorem of calculus allows us to not calculate the area of an infinite number of rectangles and then add them up, which is a beautiful thing.